Hello, Gunavati.
Yes, ma'am, it is done. We can start the
Uh,
session, ma'am.
yeah. Uh, Good evening, everyone. Yeah, we are conducting 3 days queuing theory. This queuing theory comes under 7th semester advanced mathematical methods. That is 18 Mat 753 for the then this today we are going today and tomorrow day after tomorrow. Murali is one of our alumni of BIT. Is basically is a civil engineer. Is going to give a talk based on today he is going to cover what are the basic concepts we have in the queuing theory, and then tomorrow is going to explain MMI model, and then day after tomorrow is going to explain MMI's model. Yeah, welcome Murali. You please start your session.
Ma'am, thank you, ma'am. Just a
Okay.
minute, I'll start sharing the screen.
Yeah, Madam is given. You are a co-host.
Yes, ma'am.
Murali?
Ma'am, is the screen visible, ma'am?
No, it's not visible. Uh, it's not visible, Murali.
Yes, ma'am, I'll try one sec.
Uh, Gunavati madam
Yes, ma'am.
is telling it's not. Is trying for sharing.
Ma'am, nothing is.
Oh yeah. I told it's not
Yeah,
visible.
now it is started, ma'am. Like,
Is it
yeah.
It's
visible, ma'am?
visible. Yeah. Visible. Yeah.
Yes, ma'am.
Mm. Yes.
Yes, ma'am. It's loading.
Mm. Yes, visible.
Hello all. Yes. Hello all, I'm Murli. Yes. So I'll be talking about the discussion of queuing theory as a part of 3 days webinar on queuing theory starting from today. I'll be also covering different exemplar problems, VTU previous year problems, as well as different model paper problem in this webinar session. So coming up about the details of what all the things will be covered in the 3 days webinar that is starting from today. So today I'll be covering the basic introduction to queuing theory. What is queuing theory? What is little law? Everything I'll explain. And also I'll give some basic explanation to MM1 Infinity FIFO model. Next in the tomorrow session, I'll be explaining about the problems on that MM1 model as well as other models explanation. And day after tomorrow, exclusively, I'll focus on dealing with solving of different model paper problems and previous year paper problems. So firstly, I'll just give an introduction about queuing theory. We know actually the queue is an something a part of a life. Everybody, we wherever we go, we experience this queue. For example, in the railway station, to collect the ticket, we need to wait in a queue. Or in a post office, to withdraw money or to just pay the money, we have to maintain the queue. So queue is a part of life. So now what is this queuing theory is that we are going to give a theoretical solution as well as we analyze the queue. What is the queue pattern? What is input pattern? What is the service pattern? And how the server is dealing with the queue. So this is what the queuing theory is. So next, coming to just basically the queue is that we want to collect the ticket from the railway station. We just stand in a queue, and when our turn comes, we will collect the ticket and we exit from that system. So this entire process of collecting ticket, I can call it as a system. So in that system, it is having different parts. So I divide that into 4 different parts here for easy understanding. First thing is input pattern or arrival pattern. The input pattern or arrival pattern exists only if we don't have ticket. If somebody books the ticket from online, he don't need to wait there in the queue. So that is called as input pattern or arrival pattern. So if there is an customer who is having an intention to take service from the server, will come and join that queue system. So that is called input pattern. So that means the array called input pattern. Next is queue. So if more number of customers are available and more number of customers is having an intention to take the service from a server, then what happens? There will be a formation of queue. Next, we have service pattern. Service pattern or service mechanism. There are different mechanism in which the server treats the queue. So that I'll explain in the coming slides. Next is queue behavior and customer behavior. So for example, if you take there is an some shop in the market, you will be having for a same commodity, you will be having 2 to 3 different shops which will be selling the same commodity. Then intentionally as an user, I'll be having a tendency that to see what is the cost, what is the quality of product that is available there, and also what is the queue that is formed in front of the shop. By deciding all these things, I'll come to a conclusion that let me go and join the particular queue. So that is the queue behavior or the customer particular behavior towards the server. So I'll be explaining in depth and in detail and how to apply the mathematical method to this queuing system to ease in this process. This is our topic of interest. So next, okay. So here you can see the figure. It's simply like, for example, you take a population which is having lot number of cars, and as a result, due to some rain or some dirtness, the car has been affected by dirty. Now the thing is that in a particular place for arriving and getting service, here the server is nothing but car wash. So the car has got dirt in, and now that car has to be cleaned. So this is what the service intention and the server is. Now, actually not all car owners will prefer to go and have their car washed. Only few of them do prefer it. So now, in the population of dirty cars, some of the population will get attracted towards the car wash. So that is called arrival characteristics. So majorly depends on size of population. If more the population is, then more will be the tendency of having the car. And if more the tendency of having the car, more will be the formation of dirt. And more the formation of dirt, more will be tendency to go and clean their car. So that is the size of population. Next, behavior. Some of them, this is mainly important in the business analytic point of view. So for example, if there is in a particular place, if there are 2 tea or coffee stalls, then it is something that whatever the arrivals or whatever the customers will be there will be distribution among that 2 coffee or tea stalls. Suppose assume in place of that there is only 1 tea stall, then he will be having something monopoly over his business. So that's what happens, like distribution of arrivals. Now, once after the whatever the population or customer arrived into the system, now he is a part of system. So here system means nothing but queuing system. Now, once if he come and join the system, after some time another one person come and join the system. So if there are one service like car washing, so at a time they can't wash all. There may be case, but for ideal purpose, we consider that only one place is there for washing of the car. Then there will be formation of queue, or you can call it as waiting line. So that is also having some characteristics that is governing. The first and major is that whether that queue is limited or that queue is unlimited. So if the queue is limited means the space is limited for car to be parked before it is undergoing the cleaning. Next is that unlimited. There is a wide enough space so that you can place your car and when your turn comes, you can go and clean it. So that's the thing. And next is queue discipline. In what manner queue is moving, either in a single line or in a two lines, or if there are two servers, that is. Next is service characteristics. These details of the service characteristics are available in next slide. I'll just go with that. Just go with that. Uh, Here is service pattern or service characteristic. See, before, for example, you assume there is a stall or assume that there is a car shed. Now they have opened. Now for the traffic to get in and clean their car. Now, at the start point, the first person or customer who goes and takes service, no need to wait for a queue because till that time he arrives, the system is in idle condition. That is called idle time. And now, once after one customer is taking the service, a new one comes, then you need to wait until the service of the previously came customer gets over. So that is called busy period. The period in which the server is busy or engaged and there is a possibility of maintaining the queue. So here you come to flow chart, you can see that. So arrival, so initially it is the server is idle, it takes the service. The service will begin and the service will end. So after service end, the customer who is waiting will resume that work and he continues. This is the process in which it takes place, it continues. So now, so these three are most important things, and we have come up with these things in our day-to-day life also. First come first serve basis, because for example you take that car wash or you take the ticket in the railway station. So if you go first, you will be in the first in that line and you will get the service at first. If you go next, you will be at the back and you will get the service at the late. That is, if you come first, you will be served first, or you can call it as FIFO, first in first out. Next one, last come first served. So for this, the best and practical example is that, so there is a strict teacher who is having an intention that whoever student comes late to the class, he will be asked with the more number of quiz questions than the one who comes earlier. It means the one who comes at the last will have to face his teacher first. So this is called last come first serve. That is last in first out. So this is the thing. Next, service in random order. This we have seen in many number of places. If you go to temple to perform puja and the person who is VIP or who has lot of money comes to the temple and he go in some paid darshan quota, he will be served first than the one who is waiting an hour before than him. This is called service in random order. Whoever have more money or whatever it is, they will be served first than the remaining. So this is called service in random order. Now, before starting up with a details of queuing theory, you have to remember these things. Whatever arrival that comes to the system will always be Poisson distributed and the mean is lambda. And inter-arrival time is in exponential distribution with mean 1 by lambda. And number of customers served per unit time again is in Poisson distribution with mean mu. And inter-service time is again in exponential distribution with the mean 1 by mu. And capacity utilization or traffic capacity is lambda by mu. One of the best thing that we have to tell about this capacity utilization or traffic utilization is, this is the major business tactic to improve their business. See, if more number of arrivals are there and the service time is very less, that means less number of people are served for some particular time, then there will be always tendency that the customers or whoever it is will have an intention to just switch over to another. So this is what happens. Or if you consider like you are serving more persons and there is less number of arrivals, then you are running next. I'll explain about in queuing system. There is some framework in which this queue will be managed, or I told service management. So that's what I'll explain here. Single server queuing system. Say for example, I told in a car wash, there is only one place for the car to get washed. So it is called single server. That means service is available only at that particular place. Multiple servers in series queuing system. It means, so different servers are arranged in series. That means if you want to go to service 2, then you should first clear service 1. For this, better I can tell is, if you go to some airport or in a metro or something, you will have different series of checking. So you have to first be checked here, then you go to next stage, then other next stage. That is called multiple servers in series. Now multiple service in parallel is, best example is railway station. So if you go to railway station, there will be 3 to 4 compartments or 3 to 4 cabins where they will be issuing the ticket. Now it is left to your choice that you can choose any one of the cabin where there is less queue length. Queue length where it is less, you can just go and join that. So that is called multiple servers in parallel. And most advanced framework of queuing system is multiple server in parallel series queuing system. Here the thing is that first you will be having a provision to choose whichever you want. Then you have to go with a series of whatever I can tell services. So this is called multiple servers in parallel series. So now the major and most important law that is governing the queuing system and analysis is that little law. So little law states that if whatever average number of items or customers that is arriving per unit time, you know that it is nothing lambda. Now you know that the average waiting time that the customer will spend in queuing system. That means to easily explain this, I can tell that. So if average number of customers that is arriving the system is some number, and if that number is multiplied by the average waiting time that particular items has to wait, you will be getting the average number of customers in the queuing system. So this is what little law states. Now it will be just a law. But after your next coming 2-3 slides, you will understand how this is useful and applicable in solving this queuing problems. So the most important thing is that, so the average number of customers in the queuing system is equal to the multiplication of average number of customers arriving per unit time and the average waiting time that the customer has to spend in the system. So next, yeah. So in order to represent or design a queuing model, first you need a basic representation. So any queuing model has to be represented in the manner of A dash B dash C D dash E. See here A represents and B represents the type of distribution. As I told, both service as well as arrival are Poisson distributed. So, and we know that Poisson distribution is represented with M because M stands for Marcos, and we know that Poisson process is a continuous time Marcos chain process. So we use M bar, and this is not I, this is 1 or S, something like that. 1 represents the servers, how much number of servers. That means MM1 indicates 1 server, MM2 indicates 2 servers in the system, and MMS indicates S number of servers in a system. Next, you can see in this line you have some infinities as well as k. It is nothing but the capacity. There is a many difference between the capacity as well as the capacity utilization. You will understand that in detail in the next slide. So presently capacity means how much it can accommodate the number of queues. Infinity capacity, infinite number of queue. That means nobody will restrict you to join that queue. But K means after K people who have accommodated the queue, for a K plus 1th person, there will be no place to accommodate. That is called K. And FIFO is that I told first in, first out. That means you go first, you will be get served first. So always in any of the queuing model which we study in coming days, we will always take FIFO, first in, first out. So this is about the thing. Now, one of the most important thing is that in order to understand about this queuing theory, the major thing is that how the time will have an influence on these queuing theory. So that is very important. Suppose if input parameters or output parameters or characteristics of queuing system are completely independent of time, or you can tell in collectively the total queuing system's behavior is independent of time, it is called steady state. Suppose if that not happens, then it is transient state. And one best example that you have come up in your day-to-day life, I will give example to judge that majority of our practical cases will attain steady state. Say for example, you go into the queue of something like collecting the ticket. So you are the first person, then you go to any one of the cabin. Next coming second person will not join back of you because you are already taking service. So he wants to get the service earlier. So he will go to one more empty cabin. Third person again empty. Fourth person again empty. For the fifth person, so he all one people are present in each of the cabins. So he will join all the cabins will cases. Any of the queue will achieve the steady state. That means with the time, so the thing is the people will come, he will take the ticket, he will move out. That is independent of time. But one thing is dependent of time is that I can tell is that input rate and service rate. So or I can take average arrival rate and the average service rate. I will tell an example. If you go to a temple in usual time like Mondays, Tuesdays, Wednesdays, or you will go to a temple in the Sunday. So there is a lot difference. In the Sunday, it is a government holiday. You will be having more rush. So that's what we will call it as a queue. So that means the arrival rate as well as the service rate. So, or you can tell in any of the festival season, if you visit the temple, there will be a more the queue length as well as more the service rate also. You can't stay there in the temple for a longer time and you can't come back because there are a lot the queue length, so the service rate will also be more. So that is these both are dependent on time. Now, what is the need to learn this queuing problem? See, majorly, with the time, you have to make sure that you keep a track of your customers. Because if you don't keep a track of your customers, then you lose customers. If you lose customer, you are in a lost state of your business. That's the best thing. And you have to know what is your busy time and idle time. In the idle time, you can give a break for your staffs. And in a busy time, you want them to work at their 100%. So to know that, you have to understand this queuing problems. And also to know the probability that there is no one in the system. No one in the system means at some particular time in your business or in any place, there is no person who is ready to take your service. And this point I already told that with the time, any state will achieve the steady state. Next. Okay, so coming back, these were basic about queuing theory. Now I will just add up the mathematical concept into queuing theory. So you assume let Pn of T be probability that there are n customers in the system at particular time T. So now what will be Pn of t plus delta t? That means at the time t plus delta t also there is only n customers. What does it mean? It means only these four cases. I have marked 1, 2, 3, 4. Out of these four cases, any one case have happened. So that after the increment in time delta t also, there are only n customer in the system. So first is there were n customer at time t, no customer has come or none of them has departed, or n minus 1 were there and one arrived, or n plus 1 were there and one departed, or n customer were there, one added and one gone out. Is that clear? Na? So in that manner, after t plus delta t also, you will be having a n customer. So this is one of the most important things. Now, these were basic about queuing theory and little law. Now, applicating that law into MM1 model. So this will be very interesting thing after our stage by stage, because now we are implementing. You understood what is queue, what is queue length, what is server, what is service, and what is arrival rate, what is the service rate and all. Now we applicate that into formulating this MM1 model. So first thing, this I already explained. M because arrival process in Poisson. Again M because service is also Poisson distributed. 1. So I am taking only one server in the system. Infinity means infinite queue capacity. That means I don't limit. Whoever comes first will get served first. So this is about MM1. Now, in that two things are there. First is infinite, or you can have K. That means you can limit the queue length. So if there is a availability of the space is limited, then you can limit the queue length also. So first thing is that infinite FIFO. So you want difference equations. You have to generate the difference equations. So if you generate the difference equation for this Poisson distribution of both arrival and service rate, you will be obtaining these two formulas. So after you are obtaining these two, you can find the value of P naught and Pn. So P naught is nothing but 1 minus the traffic utilization or capacity utilization, and Pn is lambda by mu power n times of P naught. So these two are most important formulas, that 3 and 4 if you want to take exam point of view. So next, so we'll see what is the average number of customers in the system. See, there may be 0 customers. For that, there is probability. Probability of being a 0 customer. There may be 1 customer, and to associated with that 1 customer, there is a probability that there is 1 customer in the system. So on till n customer, that summation will give us the average number of customers in the system. So after simplification of summation of n0 to infinity npn, I'll be obtaining the formula as, so this is very important formula we have to remember, is lambda by mu minus lambda. So this is the average number of customers in the system. So whenever in the question they particularly ask that what is the average number of customers in the system, it is lambda by mu minus lambda. Now, how we have obtained that formula? So we have taken average number as LS. So it includes both the number that is present in the queue as well as the person who is getting the service. Both are included in this average number of customers. Now, if you just leave the person who is getting the service, then average number of customers in the system will be nothing but the average number of customers in the queue, because we are excluding the one who is getting the service. So that's one thing, and it is represented by E of n. Now, I told na average number of customers in the queue. So you are n minus 1, because out of n customers that is present, one customer is already taking the service. I'm just subtracting that one customer. So remaining I'm taking. So same again, you just split up that summation and you solve, you will be getting the formula as lambda square by mu into mu minus lambda. So there it was lambda by mu minus lambda, and here it is lambda square by mu into mu minus lambda. So these are the important things to be noted. So now this is an relationship between LQ and LS. That is LQ is equal to LS minus lambda by mu, where there is a wide difference. LS is nothing but average number of customers in the system. LQ is nothing but average number of customers in the queue. So it does not consider the customers who is taking the service with increase in time. So that's the thing. So now if you want the probability that number of customers in the system exceeds k, say for example you have to know this. So that means n should be greater than k. Yes, because number of customers should be more than k. That means summation n is equal to k plus 1 to infinity. You are going to take. So if you just take from n is equal to k plus 1 to infinity, and if you solve the same equation, again you are taking summation, you are going to expand, and you just give the binomial expansion for that, and you will be getting it as rho per k plus 1, where rho is nothing but traffic utilization or capacity utilization. So now, what is the average number? Empty queue means the queue should not be 0. That means the queue should have at least one person in that. So it is nothing but E of n minus 1 divided by probability that n minus 1 should be greater than 0. So that means there should be at least one person in that queue. That means the queue should be non-empty. So after taking that, you'll be getting mu by mu minus lambda. So next is probability density function. You can just obtain the probability density function for the condition that n customers are arriving in the system. So probability f of w bar n customers are arriving in the system. So for that, these explanations, you'll be getting final answer as this: mu minus lambda into e to the power of minus of mu minus lambda into w. So this is a formula to remember for probability distribution function. Now, so we have studied about what is the average number of customer in the system and the average number of customer in the queue. Now we will understand about what is the average waiting time of the system of the customer in the queue and system. Say for example, there are n customers in the queue, and if you join that particular queue where there is n customer, then what will be your waiting time? That means how much time you need to wait to get service. So that is nothing but your average waiting time. Now you should wait in a queue for particular amount of time. Then you have to get the service. That is called service time for you. Now both together you can call it as the total time you are spending in particular system. So that is also most important. So you have formulas of Ws is equal to 1 by mu minus lambda and Wq as lambda by mu into mu minus lambda. So now you can understand the little law easily. So you have studied about little law, that is L is equal to lambda into W. What was Ls? Ls was lambda by mu in minus lambda, correct? Now Ws is nothing but 1 by mu minus lambda. You multiply with lambda, you get lambda by mu minus lambda. So here the little law will work. In order to get the relationship between the number of customers in the system or in the queue to the average waiting time of the customer in the queue. So again, I have noted that little formulas here. So the thing is that you can see here Ls is equal to lambda into Ws in the first formula, and in the fourth formula I can write as Lq is equal to lambda into Wq. And in middle two, if you have the formula for Lq, you just add lambda by mu, you'll be getting the formula of Ls. So this is how it works. Now, yeah. So after you learn about these things, now I think you will be able to answer this quiz. Okay, I'll explain this in detail so that once you will be able to answer this queue. It is said that you have understood everything that was previous to this quiz. Okay, so the question is as follows: in the departmental election at a government office, there are separate cabins governed by officials to do the following series of work. So if you go to any place for an election, you will be having a check for an voter card. Then you will be allowed to cash the vote. Then they mark some ink that you have voted. So these are the three process, and there are three different cabins to do the work. These three works to do these three works. There are three different cabins: cabin A, cabin B, and cabin C. Now, as the number of voters are less, there is a single queue. That means there are no two or three booths, there is a single voting booth with a series of surveys. If the average service time of cabin B is less than that of both A and C, average service time of B is less. That means just you go, you vote, and you come back. It is very less process. But checking for your voter ID with the list they have and documenting that all, it takes time. That is what they have given. Then what is the average number of persons waiting in the queue to cast vote, provided that their voter card is checked? Now you assume that some persons, for them, their voter card is already checked. Now you are given with the four options: less than average number of person waiting for voter card check, equal to average number of persons waiting for voter card check, zero, data insufficient to conclude about. So now I think you can think it about it for a 2 minutes, and you can just give your answers in your chat box, so that let's have a complete discussion, and let's have a revision of whatever we learned today with the help of this quiz. So please do start. You just, I have explained the question in detail. You read it once, and whichever, let it be wrong or let it be right, you give your option in the chat box. So here the major things I'll be telling. So by then you can also keep thinking and you can cast your answer. So what we have studied till now is that what is actually the queue and what is queue length. Queue length is simply nothing but how many number of customers are waiting in the queue. That is nothing but the queue length. Now, so for the queue length or for entire queuing system, to understand it in easier manner, we have divided into different things. First is the arrival rate. So in what rate the customers are being attracted towards your service. Next, the queue formation. In that you will see what is the characteristics of queue length, everything. Next, your service. So I have to, as it is a departmental election, so there will be nothing like who they will pick randomly and ask you to vote. You will be having one queue and you will take the process. So here you should remember one thing. There I have told the frameworks. I told that single server queuing system. So there will be only one server. Is this quiz question belongs to that? Please think. In single server, there will be only one server. But here there is no one server. There are three servers. See, I'm just by the time you are giving your answer, I'm just with the help of this quiz, I'm again easing your question, so you can still answer easily. So here there are three. So there are three cabins. It means there are three servers ready for providing the service. Okay, done. So it is a multiple server, that too in series queuing system. Okay, that is clear. So we were discussing about that also. Next, after we got discussed about that, we understood about time behavior. So this I can call it as a steady state. It's a very simple thing, because whoever who is present in the queue, whoever present in that queue length, so they will just come, a new person will come and add to the queuing system. So is it not infinite queue length? Yes, it is infinite queue length because it is a governmental election and everybody has to, whoever is a part of that election, voter has to come and cast their vote. So they will be given a provision. So it is not restraining. So it is infinite queue length. So yes, indeed, after some particular amount of persons comes, then it will be closed. But still, till then it is infinite. Okay, that one also I clarified regarding this quiz question. So next, I came up with dependency. It is steady state, I can tell, because once after the person comes, he cast vote, he leave the system. A new one come, he will resume the same thing. So after some time, it will take a state of steady state. So that is also clear. So now the major thing is, will it become MM1? I think at least you can respond to this in chat box. Will it become MM1? Obviously not, because MM1 means only one server. Here it's not one server. You have three servers: cabin 1, cabin 2, cabin 3. But individually, it is considered one server, because until and unless your voter ID is checked, you will not be allowed to cast your vote. And until and unless your vote is being cast, you will not be marked with the ink. Correct. So this is how it takes place. Okay, I have explained that pattern also. So then in MM1 model, coming to MM1 model, we have discussed different number of things. That is, what is, how to find average number of customers in the system. That is lambda by mu minus lambda. Then we discussed about average number of persons who is present in the queue, or you can call it as a queue length, LQ. I have told it as lambda square by mu into mu minus lambda. Please do remember the formulas also. So next, you have we have discussed about the waiting time. For that, we understood what is little a. So we understood what is little a. It gives the relationship between what is the average number of customers in the system and with the relation to what is the average waiting time for a person who has entered the system to exit from that system. So that is simply L is equal to lambda into W. What is lambda? Lambda is average arrival rate. Okay, that also I have told. So next, so once after that is done, we have explained even about WQ. WQ is nothing but what is the average waiting time in a queue for a particular person. So very important, WQ means the waiting time in a queue, and WS means waiting time in a system. LS means number of customers. Okay, so only that much thing we discussed. So in the tomorrow's session, we will be taking up about a problem, a very important featured problem on MM1 model. With that, I will be taking you into a in-depth knowledge of other models like MM1 KFIFO as well as MMS models. Everything I'll be explaining. Okay. So with that, I'll day after tomorrow go with model papers. Now let me just
Hello, Murli.
yes, ma'am.
Stop sharing, no?
Yes, ma'am. I stopped, ma'am. Yeah, some of them has given option C, most of them, and uh, some of them has given D, that is data is insufficient, and whoever has given C has excellently understood the concept. Yes, 0 is the correct answer, because it's very simple thing. The only thing is they have twisted the question. The framing has been twisted, but the thing is very simple. See, if for example you are having a voter check and you are keep on checking, they are keep on checking your vote. So that is taking some time, isn't it not? See, till the time you are being checked the vote, the B person, or you can tell the second cabin person, is free. So now, once after first person will complete his checking, he will directly go to that service, and the service B is less. The time taking for that service is less when compared to the A. So as soon as the second person gets voters check, the first person would have exited the uh, voting. Correct, na? So in that manner, what happens? There will be a zero. So answer is zero. So if you have any doubt in what is queuing system, different components of queuing system, and queue length, everything you can ask for some time. So explanation for today's session is over. So for tomorrow's, I think probably you would have taken screenshots of MM1. You please do refer it. Now in the next class, I'll explain how to implement that in a particular problem and how to design the model. So that I'll explain it in the tomorrow's class. If you have any doubt, you can ask in this time.